All right, so get this. You know how we're always talking about quantum mechanics? Like revolutionizing technology. Well, you guys sent in some really cool research from the Technion Israel Institute of Technology. And looks like we're getting a lot closer to turning that potential into reality.
Yeah.
They figured out how to use something called optical tweezers.
Okay.
To move atoms around with crazy precision.
Wow.
All thanks to the wonders of quantum tunneling.
Of quantum tunneling,
yeah.
right.
Yeah.
That's awesome. So what's really remarkable about this research is it's not just about moving atoms,
Right.
it's about controlling them at a quantum level.
Okay.
And that opens up a whole new world of possibilities.
Okay. I am intrigued.
Yeah.
But before we dive into the details,
Sure.
let's make sure we're all on the same page.
Yeah.
What exactly is quantum tunneling?
Right.
And how does it work? It sounds kind of like magic to me.
Yeah, you're not wrong to think it's a bit strange. Imagine throwing a tennis ball at a wall.
Okay.
In our everyday world, it's going to bounce right back.
Obviously.
But in the quantum realm,
Yeah.
there's a chance that that tennis ball could actually pass right through the wall.
What?
That's quantum tunneling in a nutshell.
Oh, wow.
Particles doing things that should be impossible according to classical physics.
So it's like the universe has its own set of rules, and those rules get really weird at the atomic level.
Exactly. And one of the tools we use to explore these weird rules is the optical tweezer.
Okay.
Arthur Ashkin actually won a Nobel Prize in physics back in 2018
Wow.
for developing this technique. It's essentially a highly focused laser beam that acts like a tractor beam for atoms, allowing us to trap and manipulate them with incredible precision.
So they're using these Nobel Prize-winning laser beams to move atoms around.
Yes.
And they're doing it in a way that takes advantage of this bizarre phenomenon called quantum tunneling.
It is bizarre.
I'm starting to see why you're so excited about this research.
Yeah.
What do they actually DO in this Technion experiment?
So they set up 3 optical tweezers in a line,
Okay.
almost like a tiny atomic obstacle course.
Uh-huh.
Then they carefully adjusted the distance between the tweezers to manipulate the rate of quantum tunneling between them.
Wow.
The goal was to transfer atoms from one of the outer tweezers to the other outer tweezer.
Okay, I'm picturing these atoms hopping between laser beams,
Yeah.
like tiny quantum leapfrogs.
Uh-huh.
But why 3 tweezers?
Right.
Why not just move the atom directly from one to the other?
That's where things get really interesting.
Okay.
So they found that they could successfully transfer the atoms between the 2 outer tweezers.
Uh-huh.
But the atoms never showed up in the middle tweezer.
Wait, what? So the atoms went from point A to point C without ever being at point B?
Yeah. Isn't that crazy?
How is that even possible?
It seems impossible, right? That's the beauty and the mystery of quantum mechanics. To understand what's happening, we need to remember that atoms can behave like waves as well as particles.
Okay.
In this experiment, the atom's wave function interacted with the middle tweezer in a way that caused something called destructive interference.
Okay.
It's like 2 waves colliding and canceling each other out.
So the atom's wave is essentially avoiding the middle tweezer.
Yes.
Because of this interference effect.
Exactly.
My mind is trying to wrap itself around this. It's like the atom is taking a shortcut through reality.
That's a great way to put it. And this specific method of atom transfer, avoiding the middle tweezer altogether, is a first.
Wow.
It's not just about moving atoms, it's about controlling their movement in a way that we've never been able to do before.
And that's why this research is such a big deal. Because it opens up new possibilities for controlling matter at the most fundamental level.
Precisely. And the implications are far-reaching.
Okay.
Think about it. If we can control the movement of atoms with this level of precision, imagine what we could do with quantum technologies, like quantum computing and quantum sensing.
Okay, now you're talking my language. We've done deep dives on both of those topics before, and they always get me excited about the future.
Yeah.
But before we jump ahead, let's break down exactly what makes this Technion experiment so groundbreaking.
All right. So what's really remarkable is that they've demonstrated a level of control over quantum tunneling that was previously thought to be impossible.
Okay.
By manipulating the distance between the tweezers, they were able to fine-tune the tunneling rate, essentially controlling how quickly the atoms could tunnel through the barriers created by the lasers.
So it's not just about observing quantum tunneling.
Right.
It's about harnessing it.
Exactly.
And using it to our advantage.
Exactly. This experiment is a major step forward in our ability to manipulate the building blocks of matter. And that has huge implications for all sorts of fields.
Okay.
Especially quantum computing and quantum sensing.
Okay.
Yeah.
All right, let's talk quantum computing.
Okay.
I always hear it described as this revolutionary technology, but it can be hard to grasp what that really means.
Right.
Can you help us connect the dots between this experiment and the potential of quantum computers?
Absolutely. Imagine a computer that can perform calculations millions of times faster than the most powerful supercomputers we have today.
Wow.
That's the promise of quantum computing.
Okay.
But to build these machines, we need to be able to control quantum states.
Right.
Those weird counterintuitive states of matter that we've been discussing with incredible precision.
And that's where this research comes in. This ability to manipulate individual atoms using quantum tunneling.
Exactly.
Could be a game changer for actually building these quantum computers.
You got it. One of the fundamental challenges in quantum computing is maintaining something called coherence.
Okay.
This is the delicate state where quantum information is preserved.
Right.
Think of it like balancing a spinning plate.
Okay.
The slightest disturbance can cause it to topple over.
And that's why this precise control over atoms is so important.
Yes.
Because it helps us maintain that delicate balance.
Yeah.
And prevent the quantum information from getting scrambled.
Exactly. This Technion experiment shows that we're getting better at isolating and manipulating individual atoms, which is a crucial step toward building more stable and reliable quantum computers.
So this research is pushing us closer to a future where quantum computers could revolutionize fields like medicine, material science, and artificial intelligence.
Absolutely.
Pretty mind-blowing to think about.
Yeah.
But you mentioned quantum sensing earlier.
Right.
What are the potential applications of this technology, and how does this research play into it?
So quantum sensing is another area where this level of control over atoms could lead to incredible breakthroughs.
Okay.
We're talking about sensors that are so sensitive, they could detect the faintest gravitational waves.
Oh, wow.
Measure magnetic fields at the atomic level, or even monitor brain activity in unprecedented detail.
Wow, that's incredible. We're talking about sensing capabilities that sound like something straight out of science fiction.
It is pretty amazing.
Can you give us a specific example of how this might work?
Imagine a quantum sensor that could detect minute changes in the Earth's gravitational field.
Okay.
This could help us predict earthquakes or volcanic eruptions with much greater accuracy.
Wow.
Potentially saving countless lives.
Yeah.
Or think about medical diagnostics.
Okay.
A quantum sensor could detect the presence of specific molecules in the body, allowing for early diagnosis of diseases like cancer.
So we're talking about technologies that could not only advance our understanding of the universe, but also have a very real and positive impact on our lives. It's inspiring to think about the possibilities.
Absolutely. And this research is just one piece of the puzzle.
Right.
Scientists around the world are exploring all sorts of ways to manipulate and control quantum phenomena.
So this is really a global effort to unlock the potential of quantum technologies.
It is. And it's happening at an incredible pace. It seems like every day there's a new breakthrough.
Wow.
A new discovery that pushes us closer to a future where quantum technologies are an integral part of our lives.
And it's all thanks to our increasing understanding of these weird and wonderful laws that govern the universe at the atomic level.
It is quite remarkable.
We started this deep dive talking about quantum tunneling. And it's amazing to see how this seemingly esoteric concept could lead to such tangible and transformative technologies.
It just goes to show that the pursuit of fundamental knowledge can lead to unexpected and truly groundbreaking applications.
You know, it's easy to get lost in the technical details.
Right.
But it's important to step back and appreciate the bigger picture here.
I agree.
We're talking about harnessing the fundamental laws of the universe to solve real-world problems and create a better future.
I couldn't agree more. And the most exciting part is that we're only just scratching the surface of what's possible.
It's incredible to think about how far we've come, like in our understanding of quantum mechanics.
Yeah.
It wasn't that long ago.
Right.
that these ideas were purely theoretical, and now we're talking about using them to build real-world technologies.
It's amazing.
It really is a testament to human curiosity.
It is.
And ingenuity.
For sure.
And the pace of discovery is only accelerating.
It is.
Who knows what amazing breakthroughs are just around the corner?
Who knows? It's very exciting.
We started this deep dive talking about teleporting.
Right.
And while we might not be beaming ourselves across the galaxy just yet, this research on quantum tunneling and optical tweezers feels like a step in that direction.
I love that analogy. It highlights the sense of wonder and possibility that drives so much of this research.
Yeah.
We're essentially learning to manipulate the fabric of reality at the most fundamental level.
So for our listener who's been on this deep dive with us, what's the one key takeaway you want them to remember?
I think the biggest takeaway is that we are living in a truly extraordinary time.
Yeah.
The quantum revolution is upon us. And it has the potential to reshape our world in ways we can barely imagine.
Wow.
From medicine to energy to communication.
Right.
Quantum technologies are poised to revolutionize countless industries and aspects of our lives.
And this research from the Technion Israel Institute of Technology is a perfect example of how those revolutions might unfold.
Yeah.
By mastering the art of manipulating atoms with quantum tunneling.
Right.
They've opened up a whole new world of possibilities for quantum computing, quantum sensing, and who knows what else the future holds.
Exactly.
It's a future that's full of challenges, of course.
Sure.
We still have a lot to learn about the quantum world.
We do.
And how to harness its power. But that's what makes it so exciting.
Absolutely.
There's this sense of discovery and adventure that permeates this entire field.
For sure.
Well said. And for anyone listening who's feeling inspired to learn more, I encourage you to dive into the research.
Definitely.
Explore the possibilities. And maybe even contribute to this incredible wave of innovation that's sweeping the globe.
Yeah.
Who knows, maybe you will be the one to make the next big breakthrough.
I can't wait to see what the future holds.
And that's a wrap on our deep dive into the world of quantum tunneling and optical tweezers. Stay curious, keep exploring, and we'll catch you on the next deep dive.